Hello and welcome to Pseudocode again. Today we have a recurring guest with us. You all know him. This is Gaurav Sen. He owns a website called Interview Ready. There are so many courses, material to learn from that website, and recently they have also released System Design Judge. You can try out that tool as well. But today we are going to test the teacher himself. We are just going to sit with Gaurav Sen and see how much knowledge does he possess to actually design ChatGPT. So let's get started.
Thank you, Yogita. No pressure, no pressure. Yes.
No pressure, no pressure. Let's assume that you're interviewing for a very, very senior role and you're given the requirement in order to design a system. And the requirement is very short that how would you go about designing a system like ChatGPT?
So, ChatGPT is a chat bot which takes prompts and is able to answer those prompts, is able to give text after a prompt is given. Are we looking at image generation? Are we looking at everything around it? Or are we limiting ourselves to just the text bot?
We can scope it out as we go, but for now, let's say that you have to design this chatbot which will take prompts from a user, will keep the context of prompts going on in one thread. And a user can also have multiple chats. While the user is in one chat, the prompts can go on. The chatbot has to remember the context of the previous questions and answers and just provide the information that the user is looking for. At a time, one user can be chatting on one prompt from one device. Right now, let's scope down the requirements. But a user can have multiple chats. For simplicity, we can say that a user can maximum have 50 chats.
Okay, 50 chats per user. And this is the history of the chats, in the sense 50 chats in total? Or is it that at any point in time they can have 50 concurrent chat conversations going on?
No, for concurrent, let's keep that they can have one chat at a time. They can log in from multiple devices. They can log in from phone, from browser 1, browser 2. But at a time, they can have one chat active. In total, for that particular user, the total number of chats could be 50. As soon as they go on to create 51st chat, you can reduce or remove their first chat, or you can just delete it. You can take that decision how you will manage just maximum 50 chats for one user. But this is 50 different chats. Inside one chat, the conversation can go on.
And some other questions that I have are, how quickly do we want a response? I think typically ChatGPT responds within 5 to 10 seconds. Is that an acceptable window, or are we looking for multiple models which are fast, slow, and can the user choose them?
No, so in this case, what I would suggest is, depending on the question, we have to respond as fast as possible. It can be within a second, it can take up to 10 seconds, but let's say it is taking more than 10 seconds. Then we have to kind of respond to the user. This is taking some time, we are analyzing, and even it can take up to a minute, right? So let's keep the threshold till a minute.
Yogita, would you say that 99% of all the chat responses will come within 10 seconds? And then maybe if I had to make an SLA here?
No, I would say let's keep the 80-20 rule. 80% of the responses take more than 10 seconds and 20% of the responses are within 10 seconds.
To get that right, 80%, most of the responses come quickly within 10 seconds?
No, other way around. 20% of the responses come within 10 seconds, but majority of the responses take time, more than 10 seconds.
Okay. Most of the responses are quite slow.
Yeah.
One other thing is, do we want this to be as real time as we possibly can, or is it absolutely real time, or is it fine for the last time this chat bot was updated was 2023 or 2022, the models that we are choosing?
It can depend. Actually, you can also give the user a choice to choose a model, right? Whenever they are writing their prompt, or you can give a drop down to them which model they want to go for. Let's say you have different versions of your ChatGPT model, right? You can give them choices which one they want to use.
Okay.
And you can keep a default.
So the reason I'm asking these questions, Yogita, is because I'm trying to understand how much work do I have to do before the user asks a query, how much work do I have to do during the query, and what are some maybe optimizations that I'll be forced to use for the latency. In terms of latency, I have a decent idea. In terms of the time that is needed, I'm not looking at memory. I'll try to optimize it as much as I possibly can. Same as processing power. When it comes to how much work I have to do beforehand, you have given me an idea that the user can choose different models. Are these models going to be updated at some frequency, or are we going to have them, train once and then we are done?
No, ideally we would have retrainings and we would keep the models updated. But for the scope of this particular round that we are doing, you can assume that the models are updated once in 6 months. So you can assume that for this particular system that you're designing something that should last for 2-3 years. So you can keep this requirement that models will get updated once or twice a year.
Okay, so retrainings are very rare. We might not need to look into it. And finally, when I'm looking at what do we need to do to get the responses, are we also looking at how the chatbot has to clean the responses, has to make sure nothing offensive goes, or are we not going to look at that so much right now?
I mean, that depends on. So, in this particular exercise, we are keeping the intelligence within the models as a black box. You can assume that the models are trained, they know what they have to do, and you are a software engineer who is supposed to productionize this system, right? Integrate everything, provide a chatbot, but you can consider the models or LLMs to be your black boxes.
Yogita, with this, what I'll do is I will start designing a high level component diagram. And based on that, we'll keep coming back to this set of requirements. And if we see something is missing or something has to be updated, and based on your feedback, I will be changing the design.
Okay.
Let me start from the part where ChatGPT trains itself, because the first thing that ChatGPT needs to know is actually create the models so that they can serve user queries. So this part here, I will need some sort of a search engine or a web crawler. So we have this crawler which is going to be going through public documents. I'm talking about blogs, and I'm talking about YouTube videos, Wikipedia pages, any useful sources of information, highly ranked sources of information which have opted in, maybe, or at least not opted out of this system. Now, this crawler will have various things similar to a Google search crawler. It will have a set of pages that it is going to index. So that needs to be stored somewhere.
Okay.
That will be in a file system.
Okay. Which data store would you use for this?
So Google uses Google file system. We can use HDFS.
Okay.
Or I would, if I had to do it at Interview Ready, I would use S3 because it's a object store, stores files very well, is quite cheap, and I would use a file system because HTML pages can be stored very well as files.
Okay.
Now, once I have these list of pages, I will have to process them, which is I'll have to read them. And while reading them, I will be extracting the hyperlinks from this page. So a typical PageRank algorithm is what I'm assuming. You have a page, you discover all the outgoing links from this page, and if those outgoing links are pointing to a different domain, then we rank that page high. We are also doing some sort of a breadth first search here, and then we get all the outgoing links from this page. We add these to a queue.
Okay.
As we process each page, more links are added to this queue at the end.
Okay.
Actually, PageRank algorithm was probably incorrect from my side. What I'm trying to do is I'm just trying to find all outgoing links, and I'm going levels deep. Eventually, I will have run through a lot of cycles. I cannot cover the entire internet, but ChatGPT is definitely not going to cover the entire internet. It's going to have a set of links, and it's going to go to a certain level. So let's say a depth level of 50 is what I'll do, or maybe I can set a threshold of process 1 million pages.
Okay, fine. Once you have done this, you have processed all the pages. Then how does the processed output looks like?
So when I'm processing these pages, there's two parts to it. One is getting the hyperlinks, the outgoing hyperlinks to fetch other pages. And the second thing is each page will have text. So that text has to be processed. There are various ways to process a text page. For ChatGPT, most likely what is happening is they are taking this data and creating an embedding. Every page can have an embedding.
Okay.
And we can store this embedding in a vector database.
Would you want to simplify for the viewers what is an embedding and what is a vector database?
Yes, sure. A vector database is something which stores vectors which are n-dimensional arrays.
Right.
So what is happening here is we can assume that every word is technically a token, is going to get a representation in this n-dimensional space. So if there are n values here, each different word is going to have a different representation using this vector.
Right.
Now, the benefit of this vector database is simple. Let's just take a 2D vector for now. Let's just say that it's an array of dimension 2. And if I take words like apple, banana, and system design, then my assumption will be that apple and banana are going to be close to each other. These vector representations will be close to each other, while system design is going to be far from them. Engineering will be close to system design.
Exactly.
When I take these vectors and I search for a term, when there's an input search query to ChatGPT, it can go and search in the vector database around the words that are for that vector. If I give an input query of what is system design, then it's likely that it's going to pick up all the vectors like system design, engineering, maybe computer science, all of these, and it's going to ignore or going to give less weight to apple, banana, and other vectors which are far away. We can see that there is a need for a vector database. We also see that it is going to store n-dimensional arrays, which are representations of different tokens, which will be used for generating a response. What we are left with now is how do we take these pages and the tokens inside them and convert them into vectors.
Okay.
So this is done quite well using GPUs. For most of our viewers who have used Apache Spark, the basic idea is the same. This queue with its pages can have Apache Spark processing them.
Okay.
So some sort of a MapReduce algorithm. Firstly, what we want to do is we want to take these pages, get all the words out. Those words are then going to be tokenized. Then those words have multiple processes. There's an entire pipeline of things that we need to do. So because this is processor intensive and it's a long process of many pages going in parallel, it's a massively parallel system. We can use a system like Apache Spark, but instead of Apache Spark, there are other AI, what do they call this? Farms.
Optimized.
Yeah, AI optimized farms which can do this. So for example, one of the papers that I've read on this is billion scale similarity search by Facebook. So FAISS is what they use. Google has its own farm which can do this, and ChatGPT has its own, which is not public. But if you or I are trying to do this, we can use other models like BERT is one. This takes sentences and tries to create vector representations embeddings for them. And if you are going to do this using a CPU, it is possible. It will take a long time. But if you are going to use GPUs, it's going to be much faster because the instructions, the same instructions will run in parallel.
Mm-hmm.
So at the end of this, we'll have this massive vector database with a huge set of vectors. Now, the question is, if there is an input query to this system,
right,
then we need to answer that query using this vector database. We actually don't go and read the files during runtime. We will just be using the vector database and some software engineering principles to answer queries. So let us say that there is a client. Now, ChatGPT is on mobile also. You have this server, which is going to get an input query of what is pseudocode. And then what we can do here is take this query and convert it into a vector using the same model that we had earlier. So BERT, let's say, runs through this input query and it converts it into a single vector representation, which is going to be an n-dimensional vector. Now with this vector, we will search our vector database. There is a big issue here because this vector database is going to be massive. If I have to take a guess, then this will be in terabytes because there's a huge number of documents that have been processed. Also, not all the documents will be put in the same table. We are going to segment this huge amount of data. This database is going to be sharded, needs to be, otherwise it cannot vertically scale to that extent. Also,
and replicated.
Yes, and replicated, otherwise all the work that we did would be wasted during this MapReduce process. Also, I think we'll have multiple, in the process we'll have a version v1, v2, v3 also being stored in the vector database. It will be retrained. So this is going to be very large. And if we have an input search vector, then similar to how we manage normal distributed systems, database systems, we need some sort of indexing in this vector database to find the vector quickly. One popular algorithm here is hierarchical small navigable worlds, and there are other algorithms also. I'm choosing this algorithm because it's easy to understand as an engineer for me.
Would you like to explain HSNW in 2 lines?
Yes. So the basic idea here is that we take this n-dimensional vector, we then try to find the nearest k vectors to this. So nearest is defined by some function. In our case, we can use cosine. Cartesian is quite slow. This can be done, and a vector database actually provides these functions, provides the algorithm internally, like a B tree, which is hidden for software engineers. HSNW is also going to be hidden. There are many other optimizations that a vector database can do. It's going to use codes to reduce the size of the vector. It's going to use quantization. It's going to use many optimizations, which as an engineer, we may not need to know. But as an engineer, we should definitely know that it is going to be sharded. It is going to be replicated. And if we have to find all the vectors in a particular space, let's say there are 50 vector machines here, 50 vector database servers. Amongst them, we have to find the server which is closest to our input vector. Then how can we do this?
Right.
It will be a question.
Yes.
So
Yes.
One of the things that we can do, this is also similar to the algorithm that vector databases are using internally, is to have some sort of a representative for each database. So like a centroid in a body, it kind of captures the essence of all the vectors in that data shard.
Can you give an example?
So let us say that this database has a massive number of vectors which are all around food. This database has a massive number of vectors which are all around engineering. This database has around travel. And the reason I'm, at a high level, I'm giving them responsibilities is because I know all the vectors which are close to it are related. So everything around food is over here. Yes.
Right. But let's say somebody has a query which might have related stuff. Then is it possible for you to query more than one shard at a time?
Yes, we can do that. It is going to be more expensive, but yes, we can fire the query to all the databases and get different responses from them. So we can do a scatter and a gather. While gathering, we can see how far was this vector, this input vector, as compared to its centroid, or as compared to the closest vector in this DB. Let's say that this database tells me the distance between our input vector and the closest vector, or the closest 5 vectors to it, is on average 100. And this one tells me that our input vector and the closest vectors from here are only distance 10. So this value can have more weightage than this one.
If we take a look at this whole process, once the user types in a query, there should be a pre-processing layer and then there should be a post-processing layer as well.
Yes. So the pre-processing is actually creating all the vectors, the different vector shards, the stores, and the real-time processing is going to, in real time, scatter the input vector.
No, not creation of vector databases. When the user types in the query, that query itself is broken down, right? So understanding that query, that is pre-processing. Before even going to the shards, before even going to the vector databases, there has to be intelligence in understanding that query itself. So that would come under pre-processing.
Yes. So the way to convert a given sentence into a vector, for that we'll have a model which will be in memory, and this is going to be in milliseconds. We'll be able to convert this. This is a pre-trained model which we can use open source models. OpenAI has its own model and Google has its own model, but using this we are able to actually convert this into a vector. Once the vector is converted, input vector is in our hands, we then can fire it to different data shards, or we may have those representations in cache also, and we can see what is the distance going to be like from the centroid of these shards, and then choose to only fire to the k most related shards. Internally, all of those shards are going to do the same thing. They're going to take the k most closest vectors and they're going to use that information to generate a response. So the generation part is something which again is quite AI intensive and math intensive. For our intents and purposes, if anyone is interested in reading, you can read about GAN models or about transformers. But what I would suggest is using that internally, ChatGPT is able to take these vectors and then is able to generate this response. So there are some transformers probably working internally. This response sentence, once it is ready, we can start serving the user.
Okay.
So a partial response or a full response can then be shipped to the user.
Okay. In this whole system, you would also have to make sure that your system doesn't get overloaded. And at the same time, you also have to make sure that all around the world, there might be a lot of common queries. Just the way Google suggests to you, like, do you want to ask this? Like, whenever you start typing in, there are a lot of auto suggestions that show up, right? Because people have asked similar questions. So similarly, when you have a lot of similar queries in this case, how are you going to cache the response of such queries?
One thing that I can do is I can prefetch also documents into cache when a person is having a conversation. I know that most likely the conversation is going to be alive for a while. Let's say the queries are usually landing on this vector store. Part of the vectors which are being used constantly, I can try to bring it into cache in either the database server itself, so that can be offloaded to the database server, or I can try to bring it in memory. But if I try to bring it in memory, I will still have to send it to this generator eventually.
But don't you think bringing it in memory would be very heavy because it's a lot of data?
Yes, it will also help me to actually generate a context window, because when a user has made a query and the next query is on something else, I can use the vectors which were used previously and again feed them into this generator so that it has context, what kind of response it should generate.
Okay. Actually, my question was more around different people asking the same query. But I think in this case, we have covered the conversational part of it, which is fine, which was going to be my follow-up question. But since we have covered that already, let's go back to the previous question, which is different people asking the same query. Like if 10 people are writing what is pseudocode, right? Depending on the location of the users and depending on the caching, how would you make sure in the system that for same queries, the search doesn't happen over and over again?
If there is a context window for a same user, yes, I can prefetch. But if there are different users who are fetching the same query, I could try to cache it on the server side, which is caching the vectors which are related to that query. So if there is a very hot topic, maybe I get those into a cache, but then maybe I lose some context. So I can have a local, let's say, user based cache, and I can also have a global cache. Global query cache.
Yeah.
This global query cache can try to track. The problem here is a vector is never equal to another vector. In a sense, if someone says what is pseudocode and someone else asks who is pseudocode, these two are actually extremely similar queries. And then they can also ask when does pseudocode post videos, and everything related to it is going to be considered as different queries, which will actually waste a lot of space in the cache. What I can then do is I can have some sort of a threshold in this global cache, which says that if a person asks for pseudocode, let's take the first query as this is the first prompt. They ask this question, I got a vector v1. Now someone else asked who is pseudocode, and that is prompt 2. Now I can convert this into a vector v2, check the distance between v1 and v2. If they're extremely close to each other, I can maybe just pick it up from the global query cache and ask that question. There is a chance though that it won't be exactly what you mentioned, in which case there will be a problem in the sense response quality will be a little lesser than expected, but it will save on queries for hot topics.
Okay, so Gaurav, I think we have covered good enough ground for the queries and the basic skeleton of a system like ChatGPT. Now, how would you think the systems like, in this case, we have stored a lot of data from different pages after crawling the internet. But what about the queries where we can give a prompt and ask ChatGPT or a system like ChatGPT to generate responses for us? For example, rather than asking what is pseudocode, I want to give a prompt, write a poem about pseudocode. How do you think the system will get to that kind of query?
That is more on the generation side. If someone asks for write a poem for pseudocode, let's take that, or write a blog for me. Here, this query, if it is converted into a vector embedding, I will get the vector embedding here. Let's say I get the relevant vectors which have been searched online. That helps me find out what is the meaning of pseudocode also. It could be code which does not compile. It could also be a YouTube channel. So there's going to be different meanings that I'll be able to generate from this based on the different databases. So this is the thing that you have multiple meanings for the same word that can be managed using this. It's kind of inbuilt into transformers anyway because they have context being saved. When generating a response like write a poem, that in my understanding is going to be on the AI side of generation. If I actually input this into a transformer, what's going to happen is it's going to take each of these tokens, it's going to split this into tokens, and then it's going to try to predict what the next word is like. What will happen now is write a poem for pseudocode will turn into a bunch of tokens. After that, each token is being predicted by ChatGPT. So what will come here is a poem based on pseudocode.
Okay, but don't you think that there would be a vector database which will consist a lot of poems, and there is a vector database which has crawled all the pages related to pseudocode, and then both those inputs will be taken into consideration, and then the transformers will try to apply the design of how a poem is written to the contents of pseudocode?
Yes.
Maybe that is something to, think about.
Yes, that's something I don't know. I can understand how that is at a very high level going to happen, but that is very impressive. It's able to take different databases, let's say Shelley or Byron, so able to take their poems and it's able to take something very latest, and now how does it generate something? I know how I can send it vectors, but I don't know how those vectors are actually being converted into a English response.
Yeah, I asked this question because you can even write a prompt to, you can give it a topic and you can also give it a writer, and you can say that this is a topic and write a story in Kafka style, and it can produce a story of how Kafka used to write. Kafka the poet, not Kafka the messaging system.
Yes, this is something I am not aware of. Maybe I'll read up more on this, on how the responses are being generated. I am treating that like a black box because I'm not sure how that works. Yes.
I think we have covered a lot of ground. We can move on to the problems like rate limiting or giving API keys for different users to maintain the load on the systems. But I think you have made enough videos to prove that you have in-depth knowledge of it. So I guess that is it for this round. I think this design is detailed enough. It can give a basic idea of how the system would work internally and how you can go about building a system like this. Given this design, you can even build a small POC of a system like ChatGPT. Yeah, I don't have any further questions.
Thanks, Yogita. I'll just try to see if I have covered some of the points. The context window, we did mention to some extent that we can store vectors for a conversation, and also a transformer kind of takes care of the context window by itself because it generates in a sequence. The next thing is 50 chats per user in total. This is going to be memory issue. How many of them do we want to keep in memory? Maybe an LRU cache policy per user can help us in this case. One current chat, all of the vectors, all of the useful things around that chat can be kept in memory. Maybe We can have a multi-layer cache also. One is in memory and another one is maybe in a global cache. Then we have question-based latency. I didn't really understand this unless we are talking about UX where users can see a response from the server saying, sorry, it's taking time.
Yeah, that's what I meant. That you should be able to return 10 to 20% of queries within 10 seconds. It's usually the first query that people write, or the follow-up questions. But some of them can take a lot of time. And in case your response time goes beyond 10 seconds, you should be able to send a response to the user and say that this is going to take some time, or you can show them an icon that we are analyzing, so that they know that okay, it is getting processed. If you see the UX of ChatGPT right now, it shows you like a dot or a circle which keeps blinking until you get the response.
One thing that we can do there is the first request which comes in can actually start an answer ID, basically some way to just track this request. So every time the UI pings, maybe every 3 seconds, the backend, if it has more response generated, it can give it. So you can stream the response. There's various ways where we can do this. We can poll for the answer. And if it takes more than 10 seconds, the user will not get frustrated. User choice for chat model, it's more on the generator side of how the answers are being generated. That is dependent on the chat model. Retrainings are once in 6 months.
Yeah, we scoped it out as well.
Yes, Yogita, thank you so much for taking this, and this is great. It gives me places where I can go and read up on more, and also I hope this is useful for people who are looking to just start off with where does ChatGPT, I mean, how does it do the thing at a high level?
Yeah, this was a good enough design in the small time frame that we had. It was a good round, I would say.
Thank you, Yogita. All right, folks, if you haven't subscribed to the channel, Yogita's channel, please do so. And I'll see you next time. Bye-bye.
Thank you, everyone. If you have any questions, if you have any comments, please feel free to leave them in the comment section. There are some links in the description. You can feel free to go through them. Once again, check out Interview Ready, check out System Design Judge. It will be very useful to you. I'll see you next time. Till then, take care. Bye-bye.